Implicit differentiation is a powerful technique that will help you tackle complex calculus problems with ease. Here's how to do it. First, let's quickly recap what differentiation is. Differentiation is the process of finding the rate of change of a function with respect to a specific variable. In other words, it tells us how the function is changing at any given point. Now let's talk about implicit differentiation. Unlike explicit differentiation, where we have a function defined explicitly, where y equals some function of x, implicit differentiation is used when we have an equation involving both x and y, and it's not easy or possible to isolate y. There's three different types of terms to consider when implicitly differentiating: terms involving just x, terms involving just y, and terms involving both x and y. For terms involving just x, we can differentiate as normal. For those involving only y, we'll use the chain rule. We want to differentiate a function of y with respect to x. So if we call the function of y f, for example, we want df dx. Now we can use the chain rule to expand df dx into df dy, multiplied by dy dx. If a term includes both x and y, we first use the product rule with one function of y and one function of x. The function of x can be differentiated normally, and for the function of y we use the chain rule, like we did in the last step. If we can't separate the term into a product of two functions, for example sine of xy, we'll start by differentiating normally using the chain rule, for example, and then at some point along the way we'll end up with a product of functions, one of x, one of y, that we can differentiate as before. Now let's take this all together in one big example. We'll differentiate x squared plus sine y minus e to the xy equals 0. X squared will become 2x, sine y will become cos y dy dx, and for e to the xy we differentiate the power and multiply by the original. So we'll have the differential of xy multiplied by e to the xy. So for that differential we use the product rule. Dx dx is just 1 though, so that's nice and simple. And now we'll expand this bracket and then collect all like terms that have a dy dx in them. Then take everything without a dy dx over to the other side of the equation and then divide by the bracket that's next to the dy dx. This will give us our final answer. Not a very nice function, but that's what the answer is. So that's it. That's how you implicitly differentiate a function. Thank you very much for watching. Any questions, please leave them down below.